This is TechSNAP, episode 351. Welcome to TechSNAP, Jupiter Broadcasting's weekly systems network and administration podcast. We recorded this episode on January 11th, 2018. This episode is brought to you by our three fine sponsors, Ting, iX Systems, and DigitalOcean. I'll tell you more about those great sponsors as this here show goes on. My name is Chris, and joining us every week is the presenter, the teacher, and the Meltdown expert. It's Mr. Payne, Mr. Wes Payne. Hello, Wes.
Hello, Chris.
I don't throw that term around lightly, but you have been doing some deep diving this week into Meltdown and Spectre.
Sleep? Who needs that?
Yeah, by the time we're getting on the air now, it's not news really anymore. People know about Meltdown and Spectre, but we're going to do the TechSNAP approach. We're going to go deep. We'll talk about what side channel attacks are, what the performance impact may be, and how you can assess your system currently, also where this may be going throughout 2018, and then, never fear, we'll also get in some of the other news that's going on this week, as well as your feedback. So tons of stuff for us to do. It's good to be back, Wes. You want to just jump right down into Meltdown? Just get moving?
I think we have to.
All right. Well, so as most of you know at this point, there's two vulnerabilities we're really talking about here, and these have been present in most modern computers for nearly 20 years. Both vulnerabilities exploit performance features, caching and speculative execution, which are common to many processors and can lead to leaking data via a so-called side channel attack.
Right, so we should probably discuss what a side channel attack is. So a side channel attack is any attack that's based on information gained from the physical implementation of a crypto system, rather than brute force or theoretical weaknesses in the algorithm. So you see that a lot, right? You might be able to find a flaw in how an algorithm is designed, or you might be able to just have a really powerful computer crunch through and brute force it. This is neither of those. This is the case that you have to take this abstract algorithm and implement it in silicon somewhere. You have to actually design this. It's a physical system. And as a result, there are these side channels. There's leaks of information through, for example, timing information, power consumption, electromagnetic leaks, or even sound. And all of those are little extra bits of information which clever people can use to get enough information to break the system.
Yeah, we've seen some of that on the show in the past, especially like power consumption has actually been an attack method. So these are all different forms of side channels, essentially.
Yes, and they're particularly hard to protect against because you've already designed this algorithm, and it's actually it's physical things about the implementation which sometimes are very divorced from the people writing the algorithms. Now, both Spectre and Meltdown are side channel attacks, but they are different. Meltdown is a CPU vulnerability. It works by using modern processors' out-of-order execution functionality, also known as speculative execution as well. It's able to use these to read arbitrary kernel memory locations. Now, if you're a TechSNAP listener, you probably know that's a bad thing right there. Normally, user space is prevented from reading kernel memory for many important reasons.
Right. I think the last time we talked about an attack that could sit there and slowly read memory like a bit at a time, it reminds me of Heartbleed, where over time you could essentially extract out a key or a password that's stored in RAM.
Exactly. Now, it's important to note that both out-of-order execution and speculative execution are important performance features, right? They allow the CPU to optimize many different workloads, especially when you have multiple of the same process running. It's used extensively, especially for cloud deployments. So it's important, and it's in most modern processors.
Yeah.
Meltdown in particular affects many Intel processors.
Right, you think about it, if you have extra resources sitting on your CPU and it has a pretty good idea of the future workload that's going to be requested by the user, it saves a lot of time if you can do a little bit of that ahead of time and store it in cache.
Exactly. Okay, so there's Meltdown and there's also Spectre. Spectre breaks down the barriers between different applications. So you could theoretically use it to trick applications into accessing arbitrary memory from other programs. Not the kernel, but other programs. Spectre is harder to exploit than Meltdown, but it's also harder to mitigate, and it attacks even more chip architectures than Meltdown does. So it's a wider class of vulnerability.
Yeah. Meltdown, I think, is going to be something we'll be talking about for the rest of this year, but Spectre could be something we talk about for years.
Yes, it may require fundamental changes to the way we design CPUs.
The two attack vectors were independently found by different Google Project Zero researchers. They sort of converged on these at the same time. That's back in June of 2017. And they almost immediately shared their findings with Intel, AMD, and ARM. Now, Daniel Grass published a paper that actually caught Wes and my attention back in June, but actually in the context of Linux Unplugged, called KSLR is Dead, Long Live KSLR, which introduced the Kaiser patch set, which later becomes KPTI, which we will get to. This is around June 24th of 2017. Then in November 9th, Intel informs a certain subset of partners and interested parties under an NDA. Then on November 15th of last year, Jonathan Corbett of LinuxWeeklyNews.net notices the Kaiser patch set and seems to also notice that it seems to be getting fast-tracked, and there's a lot of interesting discussion around this, or lack of discussion. So some speculation about perhaps a patch set being rushed into the Linux kernel began around November 15th in the public.
Something's stirring in the wind here.
Yeah, and then Intel and Google and others all agreed on a coordinated release date of January 9th on November 20th of 2017.
I see.
So your Red Hats, your Microsofts, your Canonicals, by this point, had all kind of come to an agreement on November 20th, so before Thanksgiving, that they were going to all coordinate their release for January 9th. That was their target date right there. Amazon then starts sending emails on December 15th, warning customers that EC2 instances would be rebooted in early January. The Sweet Python community makes a post speculating about what's the reason for this KPTI patch set, what's going on, as well as other things. I have linked in the show notes, like the PostgreSQL message board has a heads up, there's some sort of big Intel patch coming down the pipeline that's totally killing database workloads, which started a whole bunch of speculation. And then the Register published an article titled Kernel Memory Leaking Intel Processor Design Flaw Forces Linux Windows Redesign. And they had put enough of the information together on January 2nd, 2018. A whole week, really, before they were going to before this was supposed to be public.
Yeah, really. I mean, after that Sweet Python post and then the Register, the ball just started rolling, and the secret was out.
It was out, and a lot of vendors were caught unprepared, specifically the BSD vendors. We'll get into that more. And then on January 6th, Greg K.H., one of the longtime kernel developers, publishes his blog post, Meltdown and Spectre, Linux kernel status. And in this post, he hints quite heavily at some fierce discussions behind the scene and major upset feelings amongst the kernel developers, which suggested that perhaps this wasn't all of that smooth as we were led to believe by Intel. And it does seem to be there was a bit of a falling apart behind the scenes. Things were not well. A lot of vendors were left out. Most notably, FreeBSD wasn't made aware of Meltdown and Spectre until very late December.
Wow.
So they just totally left out the BSD community there. The quote-unquote Tier 2 cloud vendors, they also were uninformed, even though they have millions of customers, I would think, or at least instances. They have millions of instances that they would have to patch. So 6 cloud providers, Scaleway, DigitalOcean, Packet, Vultr, Linode, and OVH, had to come together. They created a back channel Slack.
Wait, really?
Yeah, amongst their CEOs and CTOs and engineers from the various different companies, and begun sharing all the information they had. This is a piece that we have linked in the show notes over at TechCrunch, where they have an interview, and they say, according to information provided by the companies, contact began when one of the VPs at Scaleway reached out to the Packet CEO and said, hey, I think something's going on here. And the Packet CEO wrote back and said, yeah, I'm already discussing this with OVH. We'll loop you in. And it just grew from there. And they created their own back channel network. Now, this is good and bad. They have to share information, but it also means more information's leaking, contributing to the rumors speeding up.
It also makes you wonder about, part of responsible disclosure is limited disclosure, but who are the interested parties here, right?
This was the death of responsible disclosure, and this was the embrace of coordinated disclosure. We're not calling it responsible disclosure anymore. We're calling it coordinated, because they didn't feel like it was necessary to inform certain companies, certain large Linux companies, and they informed others. And so you can't say it's responsible. It's just coordinated now.
Right. We've also seen a lot of confusing press releases trying to downplay the extent of things or really providing very little details.
Yeah, really, no kidding. But probably my favorite moment that really I think blew this thing open wide, at least it was for us, was just a couple of like just arbitrary emails to the Linux kernel mailing list. One on December 26th from an AMD developer that's talking about, oh, we're not vulnerable to this Intel thing, and he's going into some conversation, and essentially by everything he didn't say, you could essentially figure out what was going on. There was an Intel flaw. It was a side channel attack. So he kind of blew the lid on the whole thing by talking about how AMD wasn't particularly as vulnerable to it. And that was the final piece. And then the register published. And it went public on the day you were doing Linux Unplugged.
Yeah,
and it was all very vague, right?
Yeah, very vague. At the time, it wasn't clear, how many vulnerabilities there were, what the nature of them were, or the differences. So we've learned a lot in the past week.
TechSNAP.ting.com. A smarter way to do mobile. Go to TechSNAP.ting.com and get $25 off a Ting device or $25 in service credit. Why would you want Ting? Because it's simple. It's easy. It's a smarter way to do mobile. You pay for what you use. A fair price for however much you talk, text, and data that you use. Nationwide coverage and no contracts. They're not trying to trick you or lock you in. There's no agreements or anything like that. It's just simple, pay for what you use wireless. $6 for the line. They have CDMA and GSM networks to choose from, which is baller if you travel or if you have one that works particularly better in your area. A dashboard that gives you complete control. You can set usage alerts. You can check your usage with a simple glance. And they have lots of high-end, middle-level, and even budget devices to choose from basic feature phones like a flip phone all the way up to the latest and greatest Cadillac devices. Now, if you want to bring your own, I encourage that because they support, like I mentioned, CDMA and GSM, which means you may have a phone rolling around in your drawer that might work on Ting. If you bring a device, they'll give you that $25 in a service credit, and that'll pay for more than your first month on average. TechSNAP.ting.com.
As this story evolved, we saw a consistent thread running in the background. As the rumors were spreading, there were whispers of mysterious performance degradation, especially on some of the larger cloud vendors.
Yeah, like over at AWS, before the entire thing was public, Amazon had started installing patches, and they weren't specifically saying we're patching for this reason. So users were just left to log back in after the system maintenance was over and look at their CPU charts. And the forum started filling up pretty quick with, well, like here's an example. These are direct quotes. There was a AWS user says, I guess you're essentially confirming that the instance maintenance yesterday is likely the reason for the major change to my CPU usage. And now the only solution is to change my instance type. I'm not very happy about this, though, because I bought a 3-year reserved instance 2 years ago, and now I have to hope I can sell the remaining year for a reasonable amount and then purchase a reserved instance after upgrading. He's essentially saying my only solution is to pay more to AWS now because of this maintenance.
These vulnerabilities have hit cloud providers especially hard for several reasons. One is just that cloud vendors and virtualization in general has relied on some of the security features of modern processors and some assumptions that we now know are invalid to keep separate guests isolated. That's hugely important because you're going to have, all kinds of random people from all over the world running on the same machine. You need to enforce isolation between guests. The other reason is that, in particular for Meltdown, due to the nature of some of the mitigations, syscall-heavy operations, things like I/O, other times you're switching between kernel space and user space, those are all impacted with negative performance. So anything that's doing a lot of those operations, especially like databases or big cloud servers pushing a ton of network traffic, those are all going to be negatively impacted.
So is it the case where if your workload is disk heavy, CPU heavy, and network I/O heavy, it's going to be more impacted than something that's just CPU?
Well, and especially if you're switching, between the kernel and a user mode program. So if you're just some user space process humming along, and you're not making a bunch of syscalls to write to disk or other things, you'll probably don't have minimal impact. But if you are, you keep having to make syscalls to write, that'll be affected.
Yeah, okay, that does make sense. So let's talk about desktop just for a moment because people might be curious. Intel has been releasing their own benchmarks, which is a development that I didn't expect, but they're doing it because so many people are claiming everything from 100% performance impact to no performance impact. So they've released breakdowns for Windows 10 desktops, for Spectre and Meltdown. For 8th generation Intel CPUs, it's overall a 6% performance impact. It's a 7% performance impact for 7th gen, and it's an 8% impact for 6th generation processors on the desktop. Google claims that they have a way to solve the problem with zero impact on performance.
Google calls it retpooling, and it's a novel software binary modification technique that prevents branch target injection. They were able to create it. An internal engineer to Google created it. And with retpooling, they don't need to disable speculative execution or other hardware features. Instead, they modify pretty much all the programs that they're running. So this
Wow.
is something that Google can do at Google scale. It might be more widely applicable, but with this class of vulnerability, Spectre in particular, we're not sure yet. I think there's going to be more on this story, more different types of mitigations, and the various processor vendors are going to have to make some hardware level changes and microcode too.
That means that on the background, cause Google's known about this the longest, they've had the biggest heads up, and
they discovered it internally.
Yeah, and we have some links in the show notes if you want a really good read on it. The thing is, though, that also means in the background, they've been rebuilding software and patching like crazy, and they tried out different workloads in production and saw some that had big performance hits, and so this was their solution. We'll see. I'm going to be curious to follow this. We'll probably, in a future episode, if this gets more traction, we'll probably talk about this. But let's talk about the fixes that people can get their hands on right now. There has been some bumpy rides. Microsoft had to pull patches for certain types of AMD processors. Canonical had to reissue the patches for Ubuntu within 24 hours. So there's been some bumps, but we do have patches for Meltdown now.
In particular on Linux, this is known as kernel page table isolation.
KPTI?
KPTI. Part of the vulnerability here with Meltdown is that normally the kernel, when it switched to user space, in the user space's virtual memory, the kernel was kept mapped, or at least parts of the kernel.
Right.
And that helped make things like system calls and other such calls faster.
Way faster.
But because we can no longer, because of these vulnerabilities, we can no longer rely on the CPU security features to keep this clean. The kernel has to do extra work. So now only the bare minimum amount of kernel space that is required is mapped into that user space. And so there's a couple extra instructions, some cache clearing, etc., that you have to do when you switch between user space and kernel space.
Yeah.
And all of that is slow.
And I guess those are, in particular, those things are very performance costly. And that's why the kernel developers were kind of cheating. I mean, this is my interpretation of it, but in a way they were like, we don't have to worry about this because the CPU guys have the security taken care of. So we'll rely on this as a way to get extra performance. But that was an assumption that was incorrect. The CPU guys didn't have this taken care of. And now, more than 20 years later, we're making up for it in software.
Yeah, exactly. So most of the things we've seen are studies on Meltdown performance. Really, everything Meltdown is happening first. It's the easiest to exploit, and it's been the most clear problem.
It's also the one that the Linux kernel developers had the most heads up time with.
Yes, exactly. Spectre mitigation, such as retpooling, which you just talked about, as well as some microcode updates, they've kind of all just started to appear. There are also a lot of them are kind of only partial fixes, so this story is going to keep developing.
There's apparently some silver lining to all of this, though, because I've seen PCID floating around. What's PCID?
PCID is a feature in Intel's x86-64 chips since about 2010 that can reduce the performance hit from patching Meltdown. When they're making patches for Meltdown, which is present in most modern Intel processors, you have to enforce this separation between user processes, virtual memory spaces, and the kernel's virtual memory areas, as we were just talking about. So rather than map the kernel into the top portion of every process's virtual memory space, where usually just sort of remains invisible unless required to handle an interrupt or system call, the kernel is moved to a separate virtual address space. This fix prevents the malware from exploiting the Meltdown bug and reading kernel memory. But switching back and forth between these contexts involves reloading page tables. That takes a lot of time. But with PCID, there's no need to flush the entire transaction look-ahead buffer cache on every context switched. And so you can mitigate some of the performance impact.
Okay, I'm tracking you. It's a little thick, but I get it. So the PCID sort of doesn't completely fix the issue, but solves the problem of this extremely costly call process and cache flush process, at least to a certain degree. It reduces the need for all of it.
The downside, at least for people running Linux here, is that support for this was added in 4.14, so it's not on a ton of systems just yet.
I wonder, is it on my... I have a terminal window open right now. Let's see. I'm on 1604, and I have kernel 4.13.0.
Nope. You're out of luck, my friend.
Darn it. ixsystems.com/TechSNAP. Go there to support the show and their landing page with more information on why iX Systems might be a great pick for your company. From the FreeNAS Mini, which we talk about all the time, to custom-built servers for your specific workload, the TrueNAS, which is an incredible high-end storage ready to go for virtualization, or go all in with the TrueRack. They have an incredible range of products. That's why companies like Mozilla, Groupon, Splunk, VMware, SurveyMonkey, Juniper Networks, Hitachi, LinkedIn, Symantec, the U.S. Army, NASA, NOAA are all iX Systems customers, as well as GM, Shutterfly, Foot Locker, Raytheon, Sega, Warner Brothers, Walt Disney World. The list goes on because iX Systems can build a solution if you're Jupiter Broadcasting with just a few employees, all the way up to NASA. ixsystems.com/TechSNAP is where you go to support the show. Then learn more about their solutions for backup, cloud, development, education, finance, government, healthcare, manufacturing, high-tech, virtualization workloads, and so many more. They build solutions around open source, and they're the experts in the field. Storage, compute, and the open source code running on top of all of it. ixsystems.com/TechSNAP. Now, as we're wrapping up our coverage here, we got a little more to do, but let's just take a moment and do a high-level summary.
Yeah, that's a lot of information. So just to break it down real quick, starting with Meltdown. Meltdown is a CPU vulnerability that allows a user mode program to access privileged kernel mode memory. It affects all out-of-order Intel processors released since 1995, with the exception of Itanium and pre-2013 Atoms.
Oh, okay.
And a smattering of ARM processors. So far, it looks like no AMD processes are affected by Meltdown specifically.
Right. Okay.
Of the two, Meltdown is easier to fix and can largely be addressed with operating system updates alone. Now, the other one we've been talking about is Spectre. And Spectre isn't so much a specific vulnerability as a new class of attack. It's enabled by the unintended side effects of speculative execution. So far, there's two flavors of Spectres, Variant 1 and Variant 2, and you can check the show notes to go read more about the details of those. They're both, so far, the first two implementations of this class of attack that have been publicly identified. Both can potentially allow attackers to extract information from other running processes. Intel, ARM, and AMD processors are all reportedly affected by Spectre, and it poses significant patching problems. While OS-level patches and browser updates have all helped mitigate some of the aspects of Spectre, experts agree the only true fix is a hardware update.
I think you and I probably both agree that TechSNAP's going to watch stories that are about Spectre throughout 2018. As people converge on this, it's going to get easier and easier. Right now, it's this really hard thing to exploit, but that won't be true for probably more than about 3 to 6 months.
Exactly. Meltdown patches are widely available now, but stay tuned for more of those for your particular operating system, and also stay tuned for upcoming Spectre patches and firmware microcode updates.
Yeah. But I mentioned this now, and I think this is a takeaway for our audience is prepare yourself and your company, if you do IT or system administration for your company. This could be something that you have to deal with for the rest of 2018, especially as Spectre patches are developed, or as we realize that some of these patches didn't work quite as well. We've already seen Intel issue a second set of microcode updates. So prepare yourself, prepare the people above you that you have to report to. It's something to plan for. And if you want to check your system, we have a link in the show notes. It's a Spectre and Meltdown checker for Linux systems. There's also some available for Windows systems. We'll have these in the show notes as well if I can find them in time.
For all you Raspberry Pi fans out there, you'll be glad to know that the Raspberry Pi isn't vulnerable to Spectre or Meltdown. Plus, the Foundation has a fantastic blog post that details exactly why that is, and just happens to also be a great explanation of both of these vulnerabilities.
Yeah, Eben Upton, in the process of explaining why the Raspberry Pi isn't vulnerable, explains it in such a it's the best written explanation I think you're going to find. And then the best human story out of this is a surprising piece from Bloomberg Technology where they interviewed some of the security researchers who discovered this. And it's great because you have these visions of the Project Zero team in these massive headquarters with all kinds of screens, working with unlimited budgets at Google. But in reality, A lot of the initial legwork was done between security researchers that were friends at their own homes. And you get insights into the moment they realized the scale of what they had discovered. In fact, one of the quotes is, "Oh God, that can't be possible. We must have made a mistake. There shouldn't be this kind of mistake in processors." And then they talked about the work that they had to do to discover that, and how they talked to some of their friends to be like, "You're not going to believe what I'm seeing. Could this be possible?" It's a really great insight into how something this massive really kind of has a grassroots feel to it if you go read this article. So this is probably my favorite piece altogether.
It also points you to, understand just how much this has shaken the industry. Even the experts didn't think this was possible until it was discovered.
Yeah, and I think one of the stories is still to be developed, and I don't know how much of it will be worth covering on the show, but I think we'll learn more about how the disclosure and the coordination, quote unquote, went, certain companies that were kind of left in the dark, why Spectre wasn't discussed more openly, why Red Hat had patches way ahead of all of the other Linux distributions, and why Upstream doesn't even have some of the code that Red Hat had at the time. All of those, I think, will be stories that get flushed out as 2018 goes on, and we'll watch for the most interesting tidbits and share them with you guys. DigitalOcean.com. Go create an account and then use our promo code SNAPOcean. DigitalOcean is cloud computing designed for developers, system administrators, and even everyday users. How is it possible? How can you do that? It's that dashboard. It's that dashboard. It's a dashboard for days. It's beautiful. It's easy to use. And then an elegant, straightforward API if you want to take it to the next level. Everything is SSD based. If you're getting the $5 a month rig, it's SSDs. All the way up to the systems with hundreds of gigs of RAM and more cores of CPUs than I know what to do with. DigitalOcean.com. Create your account and then use our promo code SNAPOcean. Now, they also have natively integrated metrics and monitoring. This is something I'm doubling down on this year. In fact, I think it's something we'll probably talk more about on the TechSNAP program because both Wes and I are doubling down on this, and they've integrated it directly into the DigitalOcean dashboard. So you get real-time summaries right when you log in. You can get alerts about bandwidth usage, disk usage, CPU usage, my favorite disk I/O usage, and top processes. All of these get collected and graphed for you. And this is just baked right into DigitalOcean. There's so many other great features. DigitalOcean.com. Use the promo code SNAPOcean. Get started in less than 55 seconds. My favorite system is 3 cents an hour. 2 gigs of memory, 2 CPUs, 40 gigabytes of all SSD storage, and 3 terabytes of transfer. While you're over at DigitalOcean, why not go over to their community section and read about how to protect your server against Meltdown and Spectre vulnerabilities? We're covering this a lot this week, and DigitalOcean has a great companion write-up to this week's episode, including things to do if you're on Fedora, if you're on Ubuntu. It's really well done. Check it out, DigitalOcean.com, create your account, and then go over to the community section, DigitalOcean.com, new account, and then promo code SNAPOcean. No doubt about it, Meltdown and Spectre are dominating the news cycle this week, but there's some other security news that we just thought would be worth talking about. There's been several stories over the last couple of months coming out from Apple that are just ridiculously bad practices in regards to security. And neither one of them has felt quite heavy enough to come on the show and talk about because people just think we're bashing Apple. But now we have a collection of them, including one that's actually breaking today as we record this show, that are just mind-boggling. So we're going to take a moment and cover a couple of these. This one is a shocker. macOS High Sierra's App Store system preferences can be unlocked with any password. Any password at all, as long as you have a username, which gets automatically filled in, you can put in any password.
Yeah, it's pretty easy. So click on System Preferences, click on App Store, click on the padlock icon to lock it if necessary, click on the padlock icon again, enter your username and any password, literally any password, and click unlock.
Now, Apple has fixed this bug in macOS 10.13.3, which is in beta as of this recording, and the bug does not exist in Sierra. Just like this root login bug that happened recently, we didn't cover it on the show, but we did track it, and I'm sure most of you are familiar with this bug that was discovered that lets anyone log into the admin account using the username root with no password. Root with no password. It worked when you were trying to attempt an administrator's account on an unlocked Mac, you could sit down, and if you did the right incantation, again, it's like a certain set of steps. You go to System Preferences, Users Groups, you click the lock, you type in root into the username field, and then you move the mouse to the password field, you click there, but you leave it blank, then you click unlock. Now, it might fail, but then if you do it again, it gives you access. And what was happening in the background is the code, the logic that was checking to see if the account was active or what the passwords were to see if it was the correct passwords or etc., was enabling the account, the first attempt, to check it. And when it enabled it to check it, it just enabled it with a blank password and then left it on. So the second attempt, you actually could get access to the root.
Yeah, right. You typed in the right password.
And they were pretty quick to patch it. But it's been a series of embarrassing security flaws recently for Apple. And
especially as a company that prides themselves on the polish of their applications. This is
and a reputation for privacy and security. And then the other thing that is my personal issue, and it's also the same thing with Meltdown and Spectre, is Apple has a tendency to only fix these things in the absolute latest version of macOS. So you will have to get macOS 10.13.3 to have this fixed. If Microsoft did this for Windows 8, if they say they only fix Windows 10, there would be riots in the IT streets.
Could be worse, though, Chris. At least Apple isn't baking in backdoors.
Yeah, Western Digital is, though. These are pretty popular, these MyCloud NAS devices.
Oh, yeah.
I see them all over Amazon. I see a lot of people buying them in small businesses,
Small businesses, home office, even some medium businesses.
Yeah. And they're kind of useful. And turns out that a researcher discovered that a dozen models have a hard-coded backdoor. And it lets anyone log in with the password of ABC12345CBA as long as you figure out that the username is mydlink, BRIONYG.
Yeah, it looks like this is based off some maybe D-Link created firmware.
Yeah.
Sort of a fork for WD MyCloud. There was previously a vulnerability in some of the D-Link products that got patched earlier. And now eventually Western Digital has come out for a patch as well. I should note here though that some of these models can reach up to 40 terabytes of capacity. So like there could be some serious storage on here. Yeah. And I can really imagine a small business, they've got their website and then they've just opened this up to the world.
Well, here's the problem, too, is now this is out there. The username and password are just out there in articles, and not everyone's patching their WD cloud devices, because you can get this fixed if you install the latest firmware. And here's the main issue that the researcher points out is, A, this is hard-coded in, so it's on everybody's, and exploiting the issue to gain remote shell as root is rather trivial. And all an attacker has to do is send a post request that contains a file, and you can get shell access. He says he was able to upload a PHP web shell to var www and then execute that. The web shell can be executed by requesting the URI pointing to the backdoor and then thus triggering the payload. It's all out there now for anyone to use, so go patch your Western Digital MyCloud.
This isn't really the be-all, end-all, but to me it just strikes me as one more in a long line of bad practices in proprietary operating systems and firmwares where updates aren't applied automatically, or you have to jump through hoops to get them. You really have to be diligent. These are supposed to be easy to administer, easy to use, but at the end of the day, it's on you to patch and you have to pay attention.
Thanks for going to techsnap.systems/contact to send us in your questions. We have a couple of this week, but before we jump to those, I just want to mention a little housekeeping. We are consolidating all of the video feeds for this show. There are several of them. So if you are a video RSS subscriber, we have a brand new feed. Go to techsnap.systems/video for that. It is a video of the audio show. It's the visualizer for now. But in the future, if the show expands into video, that'll be the feed where it goes. And if you'd like to listen to the show like on a Kodi box or a media box, this is the feed you can use to get it in HD video. It's, again, techsnap.systems/video. And we will be retiring the old feeds after a little while. So do move over, if you will. Now, Nico writes in, and he has questions about measuring the overhead on his Windows box. He says, I have a bit of a funky situation. I'd like to get some tips. My company's IT security team has rolled out a few measures.
Ooh, I don't like the sound of that already.
Yeah, such as Triton AP endpoint, McAfee's DLP solution, and he believes a network-level DPI, Deep Packet Inspector, because a bunch of HTTPS sites were broken recently because of a broke intermediate certificate.
Oh, yeah, sounds like it.
He says, I think because of all of these, my computer's performance has gone downhill. File transfers from a network share in the LAN run at less than 3 megs a second.
Oh,
And even copying to a USB 3 device on a local USB 3 port on my computer transfers at less than 10 megs a second. My question is this. How could I measure all of these overhead performance hits so I can put in a well-educated request to adjust all of these components so I can at least have a computer that performs near its capacity? Now, my computer is running Windows 7. I do have access to another Windows 7 test computer that is not in the corporate domain, so I may be able to do some A/B testing and highlight the differences in performance. But he needs tips on where to start, on how to even do that, how to measure and get those metrics. Now, there's some good news. I will say one of the things about Windows is there's plenty of ways to measure performance.
yeah, that's true.
I think, Nico, you should probably start with just perfmon. Spend an afternoon with perfmon. Go to Start Run, type in perfmon, and it allows you to get all kinds of performance metrics. It's really surprising the things you can track with perfmon. But more importantly than that, you can do it in a logging mode. So perfmon will sit there, and it's not visually updating graphs. You're not really seeing anything while it's doing this, but it'll sit there in the background, and you can have it do a perfmon log for your entire day. So you can capture your workload for an entire day and see the disk hits, the network hits, the CPU hits, when things are waiting for resources. And just be careful how much you monitor, because the more you monitor, the more impact the monitoring takes. So keep that in mind. But perfmon's pretty legit, and you can generate these logs and then graph them. So you could do your A/B testing this way. You could work a day on the system in the domain with perfmon logging in the background, and then you could work a day on the B system with perfmon in the background. Perfmon could be a good tool.
Oh, yeah, definitely. In general, if you haven't already, go make sure to check out the sysinternals suite of handy tools for administering Windows. There's all kinds of things there, right? Like, in particular, you might be interested in FileMon, PipeMon. They have a bunch of things to get stats about different file system operations, process information. Really, the whole gamut.
FileMon might be a really good one to see if lots of different programs are like scanning files and whatnot. You know what I'll do is I'll link to Troubleshooting with the Windows Sysinternals Tools book. It's available in all kinds of places. You can also just get it online. And it walks you through actually exactly what you're trying to do and how to use the sysinternals. Also look, Wes mentioned FileMon. Take a look at ProcDump and Process Monitor. These will also help you get an idea of what's going on your system. I will link to all of that in the show notes. Let us know how it goes and if you're able to get any headway. Yep. It's really, really useful that you have an A/B comparison.
Right, and there may be other ways to exploit that. I don't know if you can make an image of your work machine and then remove components from your test machine, or if you can go the other way and install components on your test machine and then perhaps install some other. There are several metrics gathering tools you could use, things like net data, to just get some low-level graphs and then see, as you remove components, what does your system performance look like?
Yeah, I'm skeptical that all of those programs would still be impacting his USB 3 transfer rate that much. The LAN one, perhaps, but even that almost sounds more like a misconfiguration of the switch than it does network interception. But it all depends on the scale of the network and the quality of the equipment. So good luck, my friend, and feel free to keep us in the loop. Bobby writes in with our second question this week. He went to techsnap.system/contact with some MySQL replication woes. I have a quick MySQL question, he claims. Basically, I've set up a standard master-slave replication. Then from my web server, I'm sending all the writes to the master and all of the reads to the slave in order to distribute the load. The problem is that during some of the larger deletes on the master, the tables on the slave get locked, and the slave then lags, and the lag goes through the roof. During this time, all of my selects that have been sent to the slave are just sitting there and waiting for the table to unlock, while the master is just fine. This basically locks out my whole web application. I guess I could also look at InnoDB, but I was wondering if you guys have any other suggestions I could implement. Thanks again for the great show, Bobby.
I mostly use Postgres myself, but looking at some guidance from MariaDB and other MySQL vendors, I do think if you can handle some additional I/O, InnoDB is probably worth checking out. I don't know if it would be the solution that works for you or not, But it's definitely worth a look. Some tips they have are, if I don't know what data you're using, if it's something like time series or other very regular data, you can try partitioning your database. You do have to make sure that you can drop entire partitions at a time. That's what gets you the performance advantage. Not likely to happen for most sort of random workloads. The other thing that can sometimes help is deleting in chunks. You have to be careful how you do this. There are some limitations, but if you can reduce the size of your deletes that are done in a batch, that will help too.
If you have any suggestions for Bobby, we would love to hear them. TechSNAP.system/contact, and just refer to the MySQL replication woes. And if we get a good suggestion, Bobby, we'll relay it to you here on the show, because this is an area I'd like to know more about myself. TechSNAP.systems/contact. I'd say that wraps up our coverage of Meltdown and Spectre, but something tells me that's just the beginning of the TechSNAP's coverage, and as things get interesting, we'll cover them. But it does conclude this week's episode. If you want more, go check out Ask Noah 44. He had Brandon Johnson on from Red Hat, and Red Hat had a very unique perspective on the whole Meltdown Spectre fiasco, so that's a great episode. And our buddies over at our cousin program, BSD Now, just published episode 228, The Spectre of Meltdown. So I bet they have some interesting commentary on the BSD angle.
Absolutely. Lots of good JB coverage
in
this one.
Yeah, I have not. The episode 228 of BSD Now went out as we're recording, so I haven't listened to it yet, but that might be my drive home this afternoon. So you can find all of that at jupiterbroadcasting.com, as well as this show. And if you just want the links specifically for this episode, because we covered a lot of stuff, go to techsnap.systems/351. Links, download RSS feeds, everything is there. Thank you for joining us on this week's episode, and we'll see you next week.
See you next week.